If every member of society has a common interest in moving from an existing social norm to a superior social norm, it seems intuitive that local collaborative choice by members of the society would help the process along. However, we show that it is possible that local collaboration can, in fact, hinder the adoption of a superior norm. Consider individuals linked by a network. Each individual starts off playing B, the status quo social norm. We look at the gradual adoption of A, the new and superior social norm. An individual who plays A gets a payoff of alpha from each of his neighbors on the network who also play A. And an individual who plays B gets a payoff of 1 from each of his neighbors who play B. Alpha is greater than 1 and represents the superiority of norm A over norm B. Every period, some connected set of individuals on the graph are chosen to update their strategies. They change their strategies in such a way that they all weekly gain payoff from doing so. We call this a coalitional beta response. Sometimes, however, a player will make a mistake when updating his strategy and will instead play a strategy chosen at random. In an individualistic model, the sets of players who update their strategies are always singletons. All strategy updating occurs at the individual level. There are two possible effects of adding coalitions of multiple players to the model: a conservative effect and a reforming effect. For low values of alpha, there can be a conservative effect. Even when any individual switching from A back to B on his own would lose payoff, it can be the case that coalitions of individuals can switch back to B together so that every member of the coalition gains payoff. This creates a conservative effect, slowing the adoption of the superior social norm. Conversely, for high values of alpha, there is a reforming effect. Even when any individual switching from B to A on his own would lose payoff, it can be the case that coalitions of individuals can switch to A together so that every member of the coalition gains payoff. This creates a reforming effect, hastening the adoption of the superior social norm. Conservative and reforming effects occur for a variety of networks, including square lattices, graphs of overlapping triangles, co-authorship networks, workplace networks, and fragments of social networks such as Facebook. Do conservative effects exist for all networks? The answer is no. Specifically, we show that when, in the model without coalitions and without mistakes in strategy choice, the only stable networks are for all individuals to play B, or for all individuals to play A, then there can never be a conservative effect in our full model. Such networks include the complete network and the ring network. We further show that a particular type of set is immune to conservative effects for all alpha. We call this set a parochial set. Here, there is a set of 9 individuals. Imagine that they are playing A, with all other individuals playing B. Now, for any value of alpha, the individual in the center of this set will never want to switch back to B as part of any coalition, as he is currently attaining his highest possible payoff, with all of his neighbors coordinating with him on strategy A. Given that the central individual remains playing A, the individuals adjacent to him will also never want to switch back to B as part of any coalition, as by doing so they would get a payoff of 3 or lower, which is less than their current payoff of 3 alpha. Given this, the corner individuals will likewise never want to switch back. Thus, parochial sets are defined recursively and provide resilience against conservative effects. We conclude that collaboration can slow or speed the adoption of efficient social norms, depending on how much better the new norm is than the old one, and on the shape of the network. For more on these effects, see the paper Coalitions, Tipping Points and the Speed of Evolution, published in the Journal of Economic Theory, and also the associated working paper.